Bonding the conduit from one building to the other provides a low impedance path for lightning current, which helps to protect the personal computers. Additionally, ensure all personal computers are properly grounded by connecting the ground wire from each personal computer to the electrical service panel. By bonding the conduit and grounding the personal computers, protection from damage caused by lightning strikes is enhanced. The purpose of bonding is to create an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. This is particularly crucial when dealing with separate buildings or structures supplied by different electrical services, or when there are concerns about potential differences in ground potential. The National Electrical Code, or NEC, provides specific guidelines on bonding and grounding to ensure electrical safety and prevent hazards. These guidelines are designed to minimize the risk of electric shock, fire, and equipment damage. According to the NEC, bonding involves connecting all non-current carrying metal parts of an electrical system to create a continuous electrical path to ground. This includes metal conduits, enclosures, equipment frames, and other metal components. The intention is to provide a low impedance path for fault current to flow back to the source, which will then trip the circuit breaker or fuse and energize the circuit. Grounding, on the other hand, involves connecting the electrical system to the earth. This is typically achieved by driving ground rods into the earth and connecting them to the grounding electrode system. The purpose of grounding is to provide a reference point for the electrical system and to help stabilize the voltage. It also helps to dissipate static electricity and protect against voltage surges caused by lightning or other disturbances. When bonding conduit between buildings with different electrical services, it is important to ensure that the bonding is done properly and in accordance with the NEC. This may involve using bonding jumpers to connect the metal conduits together, as well as grounding electrodes at each building. The size of the bonding jumpers and grounding electrodes will depend on the size of the electrical service and the expected fault current. In the situation described, where 3 buildings are physically connected with 2 served by 208 Y/120 volts from a common service and the other by 240/120 volts high leg delta, bonding the conduit between the buildings can help to equalize ground potential and reduce the risk of voltage differences. This is particularly important for protecting sensitive electronic equipment like personal computers, which can be damaged by voltage surges or ground loops. The presence of personal computers in all the buildings, along with common ground paths through the wiring, further emphasizes the need for proper bonding and grounding. Without adequate bonding, differences in ground potential between the buildings can create circulating currents in the wiring, which can interfere with the operation of the personal computers and potentially damage them. Furthermore, a lightning strike can induce large voltage surges in the electrical system, which can travel through the wiring and damage electronic equipment. By bonding the conduit, a low impedance path is provided for the lightning current to flow, which can help to divert the surge away from the personal computers and protect them from damage. While the presence of ground rods at each building is a good start, it is important to ensure that the grounding electrode system is properly designed and installed in accordance with the NEC. This may involve using multiple ground rods interconnected with a ground ring to provide a low impedance path to ground. The NEC specifies the minimum size and type of grounding electrodes as well as the requirements for bonding them together. The testing of the ground rods to ensure they have a resistance of less than 25 ohms is also important. A low resistance to ground indicates that the grounding electrode system is effective at dissipating fault current and protecting against voltage surges. However, it is important to note that a low resistance to ground alone is not sufficient to ensure electrical safety. The bonding of all non-current carrying metal parts is equally important, as it provides a low impedance path for fault current to flow back to the source. In addition to bonding the conduit and grounding the electrical system, surge protective devices, or SPDs, can also be used to protect sensitive electronic equipment from voltage surges. SPD are designed to divert surge current away from the equipment and protect it from damage. They can be installed at the service entrance, as well as at individual equipment locations. When selecting SPD, it is important to choose devices that are properly rated for the voltage and current of the electrical system. It is also important to consider the surge protection rating, which indicates the amount of surge current the device can withstand. In summary, bonding the conduit between buildings with different electrical services can help to protect personal computers from lightning strikes and other voltage surges. Proper grounding of the electrical system in accordance with the NEC is also essential. Additionally, surge protective devices can be used to provide further protection for sensitive electronic equipment. The NEC provides comprehensive guidelines on bonding and grounding which should be followed to ensure electrical safety and prevent hazards. Firstly, consider that properly sized bonding jumpers should be installed to connect the metal conduits together. Secondly, ensure that grounding electrodes are installed at each building, adhering to NEC requirements for size and type. Thirdly, verify that the grounding electrode system is properly designed and installed, potentially utilizing multiple ground rods interconnected with a ground ring. Fourthly, consider installing surge protective devices at the service entrance and individual equipment locations to further safeguard sensitive electronics. Fifthly, ensure that all electrical work is performed by qualified personnel who are familiar with the NEC and local electrical codes. This ensures that the bonding and grounding systems are installed correctly and safely. Sixthly, periodically inspect the bonding and grounding systems to ensure that they are in good condition and functioning properly. This includes checking for loose connections, corrosion, and damage to the grounding electrodes. Seventhly, consider using a qualified electrical contractor to perform a comprehensive electrical safety audit of the buildings. This audit can identify potential hazards and recommend corrective actions to improve electrical safety. Eighthly, educate occupants of the buildings about electrical safety, including the importance of not overloading circuits, using extension cords safely, and avoiding contact with exposed wiring. Ninthly, ensure that all electrical equipment is properly maintained and that any damaged equipment is repaired or replaced promptly. Tenthly, develop an emergency plan in case of an electrical event, such as a lightning strike or a power outage. This plan should include procedures for shutting down equipment, evacuating the buildings, and contacting emergency services. 11thly, regularly review and update the electrical safety procedures and practices to ensure that they are effective and in accordance with the latest codes and standards. 12thly, consider the impact of any future renovations or additions to the buildings and the electrical system, and ensure that the bonding and grounding systems are properly upgraded to accommodate the changes. 13thly, maintain detailed records of all electrical work, including inspections, repairs, and upgrades. These records can be helpful for troubleshooting problems and demonstrating compliance with codes and standards. 14thly, establish a clear chain of responsibility for electrical safety, with designated individuals responsible for overseeing the bonding and grounding systems and ensuring that all electrical work is performed safely. 15thly, continuously monitor the performance of the electrical system and be alert for any signs of problems, such as flickering lights, tripping circuit breakers, or unusual smells. These signs may indicate underlying electrical issues that need to be addressed. 16thly, consider using a power quality analyzer to monitor the voltage and current in the electrical system. This can help to identify problems such as voltage sags, surges, and harmonics, which can damage sensitive electronic equipment. 17thly, implement a preventive maintenance program for the electrical system, including regular cleaning of electrical panels, tightening of connections, and testing of circuit breakers. 18thly, consult with a qualified electrical engineer to design and implement any significant changes to the electrical system. An electrical engineer can help to ensure that the changes are safe, reliable, and in compliance with codes and standards. 19thly, consider the use of isolated ground receptacles for sensitive electronic equipment. Isolated ground receptacles provide a dedicated grounding path that is separate from the building's grounding system, which can help to reduce noise and interference. 20thly, ensure that all electrical work is properly permitted and inspected by the local electrical authority. This helps to ensure that the work is performed in accordance with codes and standards and that it is safe for occupants of the buildings. Also, Keep in mind that the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations regarding your electrical system. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest edition. The NEC is a comprehensive set of standards that covers all aspects of electrical installations, including bonding and grounding. Failure to comply with the NEC can result in fines, penalties, and potential hazards. In addition to the NEC, there may be local electrical codes and regulations that apply to your area. It is important to be familiar with these codes and regulations and to comply with them. Bonding and grounding are critical for electrical safety and should not be taken lightly. By following the guidelines outlined above, you can help to protect your personal computers and other electronic equipment from damage caused by lightning strikes and other voltage surges. Furthermore, you can help to ensure the safety of occupants of the buildings and prevent electrical hazards. Remember that electrical work can be dangerous, so it is important to take precautions and to work safely. Always energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. The grounding electrode conductor must be sized according to NEC Table 250.66 based on the size of the ungrounded conductors. The bonding jumper must be sized according to NEC Table 250.102 cone based on the size of the ungrounded conductors.